Welcome to another episode of Learning. I thank each one of you for watching my videos and encouraging me. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We have been discussing the solutions of the problems that have appeared in the CSIR National Eligibility Test held on February 28, 2025. And today we discuss the solution of a problem from the section Complex Analysis, and the problem is related to the properties of a holomorphic function. This question is placed in part C, which is a multiple select question. There can be more than one answer, and the question carries 4.75 marks. The question ID is 704161, and this question is suitable for all these examinations. Right. The given question is, let the disk D is equal to the set of all Z belongs to C such that mod Z less than 1, that it is a unit open disk, and F be a holomorphic function on D, that is F is a analytic function on D, such that the function g of Z is equal to e to the power of 1 by Z into F of Z on D minus the singleton 0 is bounded. So on D minus the singleton 0, this new function g of Z is equal to e to the power of 1 by Z into F of Z is given to be bounded. Then which of the following statements are true? We are given four options. Option 1, f of 0 is equal to 0. Option 2, f of Z is equal to 0 for all Z belongs to D. Option 3, there exists a non-zero constant C such that f of Z is equal to C e power minus 1 by Z for all Z belongs to D minus the singleton 0. Option 4, there exists a non-zero constant C and a positive integer n such that f of Z is equal to C into Z power n into e power minus 1 by Z for all Z belongs to D minus singleton 0. Let's now discuss the solution of the problem in detail. We have the unit open disk denoted by D is equal to set of all Z belongs to C such that mod Z less than 1. Given f is a holomorphic function on D f is an analytic function such that the function, the new function g of Z is equal to e to the power of 1 by Z into f of Z is bounded on D minus the singleton 0. On this it is bounded. It is given. Right. Let us first of all study the behavior of e to the power of 1 by Z as Z approaches 0. Now, first, let us say along the positive real axis as Z approaches 0, along the positive real axis, e to the power of 1 by Z tends to infinity. Along the positive real axis, Z tends to 0, then e to the power of 1 by Z tends to infinity, right? And along the negative real axis, and Z tends to 0, negative real axis as Z tends to 0, e to the power of 1 by Z tends to 0. These two are very simple to understand. Right. Option 3, case 3, along the imaginary axis. So on x-axis, on positive side, x-axis, negative side, real axis. Along the imaginary axis, what happens? Z is equal to Iy is a purely imaginary, y belongs to R. Then e to the power of 1 by Z will be e to the power of 1 by Iy is equal to 1 by I is minus I by y, e to the power of minus I by y. Then it is cos 1 by y minus I sin 1 by y. Now as y belongs to R, and y is approaching 0 as z approaches 0, y approaches 0, what happens to the cos 1 by y and sin 1 by y? These values will be oscillating. These values will be oscillating and will move on a unit disk because the absolute value of this is 1. So they move on this one. So along the imaginary axis, e to the power of 1 by z oscillates infinitely fast, right? Oscillates infinitely fast around the unit circle in the complex plane. So from the above facts, e to the power of 1 by z exhibits extreme and unpredictable behavior as z tends to 0. This is what you have to understand. So e to the power of 1 by z exhibits extreme and unpredictable behavior as z approaches 0. Okay, let's now call on option 2. F of z is equal to 0 for all z belongs to D. Option 1, f of 0 is equal to 0. If option 2 is true, automatically option 1 will be true. Now, we are given g of z is equal to e to the power of 1 by z into f of z, and we are given that it is bounded on d minus 0. So g of z will remain bounded on d minus the singleton 0 for all directions approaching z is equal to 0. So z approaches 0 in infinitely many directions. And this g of z remains bounded. So as z approaches 0 for all directions, and g of z remains to be bounded on d minus 0, when this is possible. And on one side, e to the power of 1 by z exhibits extreme and unpredictable behavior. E to the power of 1 by z and f of z is bounded. This is possible only when f of z is equal to 0 for all z belongs to D. Then g of z will be bounded. So if f of z not equal to 0 for all z belongs to D, then g of z will inherit the wide behavior of d to the power of 1 by z and contradicting the given assumption that g of z is bounded. I will repeat. If you say f of z is not equal to 0 for all z belongs to D, for those who do not believe the above argument, if f of z not equal to 0 for all z belongs to D, then what happens to g of z? The properties of e to the power of 1 by z multiplied by f of z will be inherited to g of z. E to the power of 1 by z will exhibit extreme and unpredictable behavior as z approaches 0. This will contradict the given assumption that g of z is bounded. So therefore this is not possible. Therefore f of z is equal to 0 for all z belongs to D. When f of z is equal to 0 for all z belongs to G, in D, 0 is also a point, therefore f of 0 is equal to 0. Therefore, options 1 and 2 are true. Right. We move on to the next slide for the discussion of the remaining options. Right, that's what we have proved so far. F of z is equal to 0 for all z belongs to D. Option 3. There exists a non-zero constant C such that f of z is equal to c e to the power of minus 1 by z for all z belongs to D minus singleton 0. We prove it, and we prove that this is not true by contradiction. Assume that this statement is true. Then we take a convenient point in D minus 0 is an open unit disk. So minus 1 by 2 is a point in Z in D minus singleton 0. Then f of minus 1 by 2 will be substitute in this. This will be c e square. And c is a non-zero constant given, and e square is not 0. Therefore, the product is not equal to 0. This is for a point in D minus 0. But f of z is equal to 0 for all z belongs to D is a fact. Therefore, this is a contradiction. This contradiction tells you that your assumption is wrong, is not true. Therefore, option 3 is not true. Good. Let's move to the option 4. There exists a non-zero constant c and a positive integer n such that f of z is equal to c into z to the power of n into e to the power of minus 1 by z for all z belongs to d minus singleton 0. Again, we prove that this is not true by contradiction. Assume that this statement is true. Then, as above, we take minus 1 by 2, which belongs to d minus 0. And the value of that f at minus 1 by 2 will be c into z to the power of n. 1 by 2 to the power of n or minus 1 by 2 to the power of n. There is a minus 1 is missing, or else you take 1 by 2 here into e square. And e square not 0. 1 by 2 to the power of n is not 0. C is not 0. It's not equal to 0. So, whereas minus 1 by 2 is a point in z minus 0, but f of z is equal to 0 for all z belongs to d, this contradicts the fact that f of z is equal to 0 for all z belongs to d. So, our assumption is not true. Therefore, option 4 is not true. Right. Now, combining all the options, the answer to this question is options 1 and 2. That is the detailed discussion of the solution of the problem from the section complex analysis, which is related to the properties of holomorphic function. Right. It is in a way not a difficult question. It's only that you have to remember that the behavior of e to the power of 1 by z will be unpredictable, right, as z approaches 0 in D. Right. I am sure that you understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. I am sure that we are going to meet all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.